Hello and welcome back to Girls with Wisdom. My name is Karina Cleddy and today we are going to be learning the difference between simple moving average as well as exponential moving average. This is a complex that is a little more challenging and on a more advanced note for computer science, and we will be doing this with R. R is one of the languages that are more practical. We don't do this language too much on our channel, but we are definitely interested in continuing it if you guys are interested in learning about this language. So R is used for data sets and practical for the stock market as well as finance, and we are really opening the idea to bringing it to you guys to learn how coding is used in the real world. So the first thing that's important to learn about this is the difference and understanding the definition between simple moving average as well as exponential moving average. So simple moving average, also known as SMA, is the average price of a security over a specific period. So a specific duration of time is what is happening. So this could range from 1 day, 5 days, 10, 15, and so on. However, the exponential moving average, or EMA, is more of the weight and the more recent prices that are going on and reflect to the new market data. So mainly the difference between the two is really shown through the long-term averages that you will see in the graph after we start coding. The first thing we need to do is to import a few things. So we're going to do import numpy as np. This is just a standard importation, and then we're going to import pandas as pd. After we do this, we have to import a few more things, and that's just import pandas underscore data reader as PDR and as PDR. And then we have import matplotlib. If you're not familiar with matplotlib, this is how our graph will be shown. And with R, you are going to have your graph created for you with the data set you entered. So finally, the last thing we're importing is the percent of matplotlib. This is going to allow for colors to be shown in our graph. The next thing we need to do is to enter the data from a certain stock market. So you can pick this from whichever one you want. I personally am familiar with the Yahoo stock as I know the code for it. So I'm going to enter GLD, which is for the graph, is equal to the pdr.get underscore data underscore Yahoo. You can do this to ever stock you like Apple, Nike, Netflix, whichever one you prefer, and we'll be doing a colon for GLD. After we have this, we're going to do, I was going to be doing this year's election, however, that is not updated online for coders to download, so I'm going to do the past election of what was happening during the stock market with Yahoo. So I'm going to be doing the date of the election for 2016, which Donald J. Trump won, and that was 2016, November the 8th. I was planning on doing Joe Biden, however, as I was saying, the computer science code to download it is not available until a few coming months for it to be able to coders. So this is already downloaded and uploaded for the public. After we have this, we need to figure out what the data sets were going by the highs and lows of that day. So we have to go to files, which will be shown when you download R, and I did Yahoo, so it's showing the Yahoo data set is right here. Okay, so this is what the output is. So for the dates of 11/8/2016, its high was 123 and its low was 121, and it also prints out for the 14th, that's where it goes to, it died down. So as you can see, since Trump won the election, Yahoo did decrease a little bit. Its low was 115 as compared to what it was 121. So after we have that, now we are going to be plotting the unneeded data that will be given to it. So what we're doing now is the GLD underscore close. Now this is going to be equal to PD data frame for gld.close. So we have the gld.close, and we need to now set the dates. So we could do the moving period for whichever comfortable you want, or as well as what your compiler will allow you. For me, my R and the version I have, the maximum I could go to is 21. So I decided to split it in the middle of 21, which is around 9, from 9 to 11, and I decided to do 9, and I'm doing the GLD underscore close is the bracket for MA underscore 9. The reason as to why we're underscoring it is for the computer science language of R, it doesn't allow you to do camel case, which is something you would do in Java. So to connect it together, we have to use an underscore. And we're closing the bracket and setting that equal to GLD underscore close dot close ruling. So after we have this, we're doing the mean of dot shift. After this, we have to do it for the last date, which is the 21st. So we're going to copy this exact line and do the same thing for MA of 21. Once again, you can switch this to whatever is the maximum your computer compiler or language you are using will allow you to. So GLD underscore close dot capital C close ruling for now, instead of 9, it's 21. And we needed to find the mean as well as, you don't need to say the shift because we already had the shift in the one above. After we have this, we need to get the print of what the data looks like. So for this, it should be the election date. Exactly. So this is what it refers to as online. So this is the float. So float for coding, as we know, is showing the variation of data from the different dates and what the stock, how it dipped down. It was constantly a descending relationship. To continue the code, what we need to do next is to plot the data for the graph that will be showcased. So we are doing PLT, which is plot.figure. And as a result, we have the fig size. Once again, you have to be careful. You are not camel casing. And we have the parentheses of 15 and 10. We have double parentheses, make sure, because we have one right here and the other right there, so we have to be very careful. And now we're doing plt.grid, and then doing capital T for true. So the plt.plot, opening GLD underscore close. Now we have this to close, and then we're going to label the equal sign. Make sure you are careful with your syntaxes as well as your runtime errors. That is a big issue that can happen, and you don't want to do it at the end of the code where you're going to have to debug at the top. It's really important that you are careful with how you are wording it. So now after this, we are going to be doing the specific date. So we are plotting first from plot GLD underscore close, and then we are doing the same thing with MA underscore 9. And after we have that, we are going to be doing the label of is equal to MA 9 day. And then we're doing, once again, PLT plot, but this is for the MA underscore 21. We are doing the label once more, MA 21 day. So I realized I forgot to print this out. We have to do the GLD underscore close. And it should now line up. We have our plot for the 21st day. Close your brackets. And now the last one is the PLT dot legend LOC is equal to 2. So now that you have your code running, you're going to do this, and we have to save it for the graph to work, and we are going to save this as Yahoo. And once it's saved, the graph should be labeled as the map plot. So it's going to print it out. And as you can see, we have our color coordination here when we were doing our codes for our plots. It labels it at the standard for blue, orange, and green. So we have our orange, which is showing the average, the SMA, which is the simple moving average, for 9 days. So for the occurrence of that, you could see the dip in the stocks. It was descending, then accelerating, and little bumps in the road. But the 21 was more consistent. Over the longer duration of time, it shows that in the green, it was a more consistent maneuver. And the GLD is just the occurrence of generally not specific to either one. And those are the 3 meanings of the different colors. So as you could see, that was that. The last thing we are going to be doing is the historical volatility. So what that is basically going to print out is very simple code, and there's GLD of the close and then bracket for volatility. So you have your GLD underscore close, and what you're doing after that is your change rolling of the 21, because it's the 21 days we did, .std. Open the brackets, and you're doing your shift once more. After your shift, make sure you have your parentheses. And you're going to be doing another GLD. So you can just copy this line and enter right here and change 21. You don't need anything after plot, actually. So you have your volatility dot plot. And to ensure that, you're going to command it all and go to your files, which should be called historical volatility. As you can see, this is the volatility of what is happening over this certain duration of days. And as well as, if you're not sure what volatility means for stocks, it's essentially showing that the most mean. So there would be a line right here. It's just imaginary for the code that's not going to print. And it's just talking about the arguably most misunderstood concept with investing. It talks of the range of prices and the security for the experiences over a duration of time. So that concludes our lesson for coding using finance and talking and maneuvering that with R. I hope that was helpful. If you have any questions, please feel free to email us at girlswithwisdom@gmail.com or direct messages on Instagram at girlswithwisdom. Thank you.